Okay, hello, welcome. Welcome to the Hive. So my name's Rob. I work out of the Santa Monica office for SideFX. And we're going to talk about using Houdini to make assets, to make variations on assets, make a lot of assets. And we're also going to cover a little bit some new technology that we came out with called PDG. So to start off, I'm going to talk a little bit about proceduralism. How many people here already use Houdini, and how many? Yeah, so most of you do. Okay, and Bill too. So with traditional methods of modeling, it's usually destructive, right? You model something. If you pull points around, you can sculpt it, but then you have to save out that version. If somebody comes back to you and wants to make some changes, then you have to kind of start all over again. If you're lucky enough that you saved out an earlier version of the scene or of the model, then you're like, great, I can go back to that. But it's not very flexible. So as you know, it's with Houdini, it is procedural. It's not procedural in the way, say, something like No Man's Sky or Minecraft is. But it is a way to to be a component of prototyping and content creation and level building. It's about giving the artists tools that they need to describe a creative process that they use to make that content. It's not just automation. I think sometimes, especially for people new or reluctant to adopt Houdini and think about proceduralism, they think it's going to be just a lot of repetition and seeing the same thing over and over again. But it's not that. You can, one of the bonuses is you can create random results, but then you can work on that and give it kind of your own flair. And it's not about removing the traditional tools either. I mean, you could still work however you want, but you can use Houdini to make tools that will help you enhance your content. So as we know, in this example here, this is just a pipe tool. It seems to be the first thing that everybody wants to create when they are trying to come up with an asset for a game engine. And it's that single curve that you draw, and then the digital asset is doing the rest of the work for you. It's figuring out where the corners should be, where all the flanges are. You can control the width and such of each little component, and you're only having to modify the 4 parameters at the top there, at the top of the HDA. So the way it all works is it all starts with Houdini, where everything that you create becomes a node. That includes when you're modeling in the viewport. Each time you drop down something, it's creating a node so that you have that history. And those nodes are wired together to build a more complicated network. And that network is essentially giving you a recipe for whatever it is that you're creating. And that network could be processing geometry that came from somewhere else or creating geometry from scratch inside of Houdini. And that recipe, you can just keep using it over and over and over again to get different results and get variations. So we're not really talking about procedural modeling today, so I'm not going to spend too much time on this, but we're going to be working on sort of a highway New Jersey barrier. So I just want to give you sort of a peek at the modeling process for this barrier. And I also want to point out that I am in the viewport here. So for people that want to model in Houdini that think, oh, everything's a node and it's a network and it's not what I'm used to, we've worked really hard over the last several versions to start to provide better modeling tools in the viewport so that to give people that are modelers sort of a tool set that they're used to. So here I'm just, I have some pieces that I modeled. I have some other pieces I took from somewhere else, like these tubes, that I'm just going to use to Boolean out the shape and start to form the shape of this barrier. And I'm going to add a little bit of beveling. Here I am doing it in the viewport, or in the network view, but you can also do all these things you have access to in the viewport. So as I adjust the beveling a little bit more, I'm also going to increase the resolution a bit here because I want to, for what I'm going to do, I'm going to add some noise to this to crunch it up. And so I'm going to need a lot more resolution on the geometry. So now that we have that barrier that we're going to use as our starting point, we want to add some detail to it. And then what I'm going to do is we're going to take a look at using wedging to create lots of variations on that detail. So if we take a closer look here, so here's that barrier with a little bit of some crunch to it, some details that I added. I created an HDA that is basically bullying out the tips so that you get some damage there. And then I have two SOPs below that we call them mountain SOPs in Houdini, which is essentially point noise. So I'm just adding some noise to the barrier, and then I'm bullying out those shapes to get what you see here. And you see as I move the sliders around, especially on the damage tool, it's sort of scattering the points on the top in a different direction so that the chunks are changing. So we've always had wedging inside of Houdini in our render operators, but now we've introduced something called PDG, which stands for Procedural Dependency Graph. And it really opens up lots of possibilities and also makes this wedging a little bit easier and a little bit easier to track. And so we'll get a peek at that in a moment. So here it is inside of what is called TOPS now. That's PDG, it's TOPS, which is task operators. So you see I have 3 wedge nodes that I've set up here. And so the first one is the first base offset for the first noise parameter. And I have 10 wedges of that. And then below that, I have 4 wedges of some noise height. And then below that, I'm wedging the chunks that are being taken out. And so as I process that wedges, it's almost instant. This is not sped up. And as I click on the dots, it's showing me all that information, all those wedge values that were applied to those different parameters. And what's nice about that, in the old wedge, you couldn't do that. In the way we did it before, you kind of had to either write out that information to a variable and maybe bake the geometry and try to dig that out. But now you can visually take a look and click on all those, and all those lines that it's creating for you is also showing you all the dependencies. So if you ever at one point wanted to dirty only one of those wedges, you could, and it would generate or regenerate anything below it that it has to. So here we see, this is the look at the first wedge operator. And that's the one that has the 10. And you see there pointing to offset X, and then it's also the path. So this is very similar to how we used to do it in the old wedge drop as well, where as you know, with Houdini, all those objects or all those operators is very much like a directory tree. And so you just navigate to the parameter that you want to change and you put that in. And so that's what I did here. Here's the secondary noise height wedge. So again, that's one parameter. I'm changing the height. And then the last one, in this particular case, I'm doing 2 parameters. And this is the chunks of that is being taken out of the barrier. So now, once those 2 wedges are complete, like I said, we click on the work items. And now I'm going to expand my setup a little bit. Whoop, let's go back. It doesn't look like it's playing. Play. It's not playing. Okay, so what I did here is now, before I just was creating the wedges. So all it was doing was taking those values and storing them somewhere, and I was exporting them to the environment when I'd click on the dots. But I want to do something with that information. And so with this setup, I built something where I take that noise and I use it as a mask, and then I build some textures from that I bake out. So now I add that bake manch for textures node underneath that, which is just a ROP render operator. And now it is also all connected to all of those work items before. So you see it's generated all the work items underneath. And so now we can see a bigger setup of that. So here we see it cooking. So now the next thing I want to do is I take those baked out textures and I run them through a compositing network inside of Houdini. And again, all of these, as I click on those work items in the middle, you see that it's showing me all of the dependencies. So even if like one of the frames just failed for some unknown reason, you only have, you'll get that visual feedback. It'll be a red dot. And then you dirty that work item and it's going to recook everything that is affected by it. And you don't have to do any of the tracking of, tracking it down. That is sped up, by the way. It doesn't go that fast. Here's just another look at the COP network that I built. So I wanted to show this just because, first of all, there may be some new users that don't realize we have a compositing component to Houdini, and also just to just really highlight how nice it is to work in all these different areas to create. This is another way to help you create these variations. So everything works together nicely in that Houdini way. So now the process has really, I've really built up this network a little bit more. So once those compositing nodes are done, I'm then going to take those and I'm going to render an image. And it's just going to be a little image so I get a feel for what the barrier looks like. On the left-hand side, that's another new view for us, which is called the task graph table. And that's showing you all the tasks. It shows you the index or the work item number. It shows you how long it's taking. All of these work items are also can be color-coded so that as things are, if there's a bottleneck somewhere, or it'll show you visually what processes are taking longer than others based on the color of the work items. And here, for this, it's running pretty smoothly, so everything's still green. So what I'm doing here, though, as I wait for each of those compositing networks to finish, I bring them in, and then I render the image of each one using those textures that I just baked out. And so the way that works is that we have a variable called wedge index or wedge number. And so if you feed that in just as you would like a frame value, you can write out your wedges that way. So per wedge, it's using that wedge number, and then you write out your geometry or any of your images that you want to render out. You just include that number, and that'll help you sort of separate them. And then at the end, we actually have a node for image magic, so that we can create a sort of contact sheet of that. And so that's what that looks like. So there's all 80 barriers that it might be hard to see from there, but they are all different in some way. So now this next example, this is sort of the same thing. Now in this case, I'm using an HDA for a blade, for a sword. And what's nice about PDG and TOPS is that we have what's called an HDA processor. And so what that means in my top network, TOPS, by the way, or PDG, is also available as a standalone piece of software. So, which basically you open it up and you only see that. You don't have access to SOPs or anything like that. But so you can manage networks that, like in this example, you could take an HDA. If you have an HDA that processes some geometry, you use an HDA processor to run that HDA without loading Houdini or opening Houdini at all. So it's just a handy thing to kind of have this little pipeline in your back pocket. So in this case, we're no longer pointing. This is another new thing with the new wedging. Before you would navigate to that spot in your network, but now you can actually just set the attributes, or you name the attribute whatever you want. In this case, it's grip length or blade length. And now that attribute is being exported into your environment, so you use it just with an at syntax, just like you would some vex variables in whatever it is that you're changing. So you see here on the left-hand side where the green is, that I have those variables that were set by the wedge in my asset so that it's controlling what the sword looks like, as opposed to before where you had to explicitly set that path. Now you do have the option to do both. It's up to you however you want to do it. So here's just a look. There are 3,200 different swords here, because that's why not? And so here's just a quick look at some of those variations. And the nice thing too with wedging, every parameter in Houdini is wedgeable. So even if you've added a ramp parameter, you can wedge the the indicators for which part of the ramp where it is, the position and the value. All of that stuff is wedgeable. So in this particular case, that shape of the blade is being controlled by a ramp like that, and I can wedge all those parameters if I wanted to. Here's one more example. It's all about variations today. So here is another OTL or another HDA that really just makes a brick wall. And so it's fairly simple setup. You can change the number of bricks, change the height, change the width. You can change the spacing however way you want, just to come up with some sort of generic brick wall. And then from that, we're going to set up some wedges on this, so that the goal here is what we're going to try and do is we're going to get some variations on the wall, and then you can use those variations to drive an RBD sim, and then that RBD sim can drive a smoke sim for the dust or whatever when it gets hit. So there you see it immediately generates those work items for me. And it's important to note up top, you'll see in a second, it says export to environment, which is what enables you to see those variables as you click on those work items, as well as override. So what that override is doing is allowing you to see the changes in the viewport. So let's put down another wedge node here. And the reason why, so another important difference, I think, is in the old wedge drop, you could have as many parameters you want on one wedge drop, and you were able to individually specify the number of iterations per wedge. So in one parameter, you could say, I want 5 variations of this, and the next one could be 10 variations, and you can do it all in one drop. In tops, we have to do that differently, and we use the wedge index parameter to make sure that that's how it lines up each wedge. So like similar to the barrier example, if I had 10, 5, and 2, then I would get the appropriate amount of wedges from that. All right. So there you see in the viewport, you're seeing some of the results of our wedging efforts. So from here, I can render out and generate a contact sheet for those. So you can say, all right, now I've done this and I want to see what it looks like and I want to pick the one I like the best. And again, all being tracked by work items. Now, when you're doing wedging and you have all those individual work items, if there's ever a part where you need to gather things together, we use what's called, you could wait for all. So then it basically brings it back down to a frame-based situation versus using the wedge index. And the nice thing too, all of these things can be generated before you actually kick off the job. So you'll see all of your work items. You click on each one, and you see what all those dependencies are before you even start the processing. So now that we have our wedging set up, for that we're going to do an RBD sim. So we just take the sphere. It's a pretty straightforward RBD sim. And there's our top network again. And this is going to kick off the simulation. And you see there, as you click on those wedges, that the bricks are changing. So it's running, so it's taking in all of those different variations you made on the wall, and it's going to run a sim based on each one. And so you see as it kicked off, that little green block in the middle is just pertaining to that wedge. So those are the frames that were generated there. This is just a quick little glance at it populating in your file browser. You'll see that each one of those it says RBD variations and then has a 0 before the frame number. So that's where I'm using the wedge index to identify which sim that came from, which wedge number. And here's a much bigger, again, another broader network. So this is where we're getting that final result. We have the variations on the geometry. We run it through an RBD sim, and then we take that RBD sim and then we use it as a source for our fluid sim or our smoke sim. And when we're done, we can generate, again, a contact sheet using ImageMagick so that you can sort of have one-stop shop to see what your variations look like. And you can use that for anything. If you're making pyro, if you're going to bake out pyro to be used as a texture sheet, you can do all your variations as well first and see those parameters and say, oh, you pick the fire that you want, and then use those values to generate the final images. And all of this works with HQ. On the left, that's what it used to look like. Now, this is what it looks like inside of Tops. It works with HQ. It works with other schedulers. Other schedulers as well, such as Deadline or Tractor. There's a lot of other nodes included in PDG that really help you talk. There's plenty of Python nodes to kind of expand your reach, that you can write custom stuff for yourself. Perforce nodes, things like renaming files. Like you could really string together a pipeline from this, which is kind of nice. And then using HQ, that means all this parallelization that you're taking advantage of with wedging or whatever it is that you're doing. If you have HQ or any sort of a compute farm, you can distribute that out to multiple machines. This is just a quick example of that you can roll your own nodes if you want to. I worked with David Larson over at Algorithmic on this a little bit. He built some Substance nodes for me, and also Adobe sent us a Photoshop node to make a contact sheet. So it just runs. So as this finishes, it kicks off a Photoshop action to make a contact sheet. So from that, but the rest of the process, I used Substance Designer instead of using the texture. In the original one, the textures were ones that I made inside of Houdini. But then we also were able to incorporate Substance with the nodes from David to add that variation to their textures that I used to then bake out the render. And that's it.
what dirty means?
Sure. So dirty just really basically means it can be dirty for a variety of reasons. Most of the time it's because it needs to be reprocessed. Like you've decided that this data is old for whatever reason. It could be something as simple as maybe you just had a bad frame, or the geometry was bad when it was written out, but it completed successfully, right? So you could dirty it manually by hand if you have frames that fail. So dirtying is basically saying, if you can imagine, what the dots look like, and say this one I know I need to redo for whatever reason, I'm going to mark it as dirty, then PDG knows what all of the dependencies for that work item are. So it will dirty all of those automatically, and then you just cook the output of that. And so it'll redo everything. Then it's clean. Exactly. It's like data laundering.
Substance.
Nope.
The substance bake node, is it using the substance engine?
It's using, it's talking directly to substance. It's using the substance automation toolkit. Yeah. These will not, these will not be shipping with Houdini. What probably will happen in the not so distant future, if you guys are familiar with Orbolt, we'll probably have we'll add a tops section most likely to Orbolt that then people from the community as well as them can contribute there, or we'll put them there for people to download if they want to use them.
Yeah. Can you show us HQ slide again?
Sure.
And
this one.
sort of, can you repeat what you said again?
For the most part, it hasn't changed. It's just we have, we have the idea of schedulers in top. So everything needs a scheduler. So if you're not using HQ, there's also by default, there's a local scheduler, which is just pointing to your local machine. So the idea is just that if you choose to use HQ or deadline, that will manage the jobs. All those work items will be sent to HQ that way. So it's not that much different than how it worked before.
So that those queues or jobs will be assigned by PDG?
Yes, but PDG is not the scheduler. It's just,
right.
Yeah, it's just putting it out there. So
putting out to run action to HQ.
Yeah.
From Houdini runtime or how? Okay. So yeah, I don't get the timing when we run jobs in HQ from PDG. Yeah, that's my question.
When the done jobs are done in HQ, it tells PDG. So as they complete, you get that feedback that the jobs have completed.
Okay.
Is that what you're asking?
The running job is from, we can do that from PDG?
You're submitting it. So you're not tracking the job in PDG. It's just the way you would run a sim on PDG. You would submit it and it goes to HQ and you wait until it's done and you get that data back. So the difference is that you'll be able to track as those jobs finish on the farm, but once it goes to HQ is dealing with it. Nothing is happening on the Houdini end anymore. You're just waiting for those jobs to finish.
So like sending command line as a submitting?
That I would have to ask Ken. I'm not sure what they're doing. Yeah.
So inside Unity, I saw that there is a nice UI about how the tasks are done. Is that a similar stuff being worked on Unreal? Or
That's been
is there inside Unreal that's missing right now? So
right.
You guys working on the
It's
Unreal
coming.
side?
Yeah, it's coming. Yeah, I don't have a date for it yet, but it's coming. Yeah.
Any specific example for the game aside generation?
For the game generation?
Game aside, like game models or others?
Like LODs?
Yes.
Yeah. So, the barrier there, so when I was baking that out, that was a game res object eventually. So I'm using our baking tools to write out those textures, and it also is at the same time doing a poly reduction on that stuff that then I read back in and apply just as normal maps. So that's what that COP network I showed was generating the normal maps and the roughness and the albedo. So yeah.
Okay.
I think we have 1 minute left. Sure.
Could you talk a little bit about the per-force integration?
I can't because I don't know it. I don't use Perforce that much, but I could find someone that could talk about it for you. I can find them outside. Yeah. I think we're out of time.